Testing. Mic check. 1, 2. All right, we're ready to go. Let's start. The first question. Mind you, I actually haven't been doing my revision. So let's just get on with it. The first question, the random variable x takes the value x with probability k squared. K is a constant and x takes the values -2, 1, 2, 3 only. So let's think. So we have the probability of x taking x is kx squared. But then we have values -2, 1, 2, and 3. So draw up the probability distribution, which is a table. But firstly, let's find all these values starting from x is equals to -2. We have k -2 squared, or 4k. And we have x is 1, k1 squared equals to 1k, and x equals to 2, k2 squared equals to 4k, and then we have x equals to 3 equals to k3 squared, or 9k. Then you'll have to sum up, and since the variable can only take these 4 values, the sum of all these probability should be equal to 1. So we have 4 plus 1 plus 4, that's 5, 4, 9, 9, 9, 18. Or 18k should be equals to 1. Therefore, we obtain k is equals to 1 over 18. And then so we can substitute back these values. We have 4 over 18, 1 over 18, 4 over 18, and 9 over 18. Now this part is optional. You can either simplify these fractions, but I believe, in my opinion, it's simpler to just let it be that way so that all the denominators are equal, so that it's easier for us to see that the sum is equal to 1. So let's start drawing the table. I'm going to make it this shape and draw a line dividing. Then we have four different values. Then we can go ahead and fill in our x here. Px is equals to x. Then we have 2, 1, 2, 3. We have 4 over 18. I think I should maybe decrease my brush size, but I'll do that in the next question. Now to verify your answer, just make sure that all these values sum up to 1. It cannot be more than 1 or less than 1. If it does, then that means you have an error in your calculation. So maybe this is better. Yeah, that might be better. So now find EX or mean. This is just -2 times 4 over 18 plus 1 times 1 over 18 plus 2 4 over 18 plus 3 9 over 18, and then we will get that answer. So I'm putting our values into my calculator. I obtained 14 over 9. Hopefully I didn't make any mistakes. From the look of it, it's pretty much correct. Next we have find the probability of x is not equals to 2 given that x is greater than 2, which means it's the probability of x is equals to 1, 2, and 3. And probability of x is equals to -2, 1, and 3. So if you draw up a Venn diagram, it's just the union of these probabilities. So we're just gonna add up all these probabilities, I believe. So the first one is just -2 is 4 over 18, and plus 1 over 18, then plus 9 over 18, and then we divide by 1 over 18 plus 4 over 18 plus 9 over 18. And if you put it in the calculator, I think we're supposed to get 1. We'll verify the answer later. So, moving on to the next question. We have a fair 6-sided die with faces labeled 1, 2, 3, 4, 5, 6. Thrown repeatedly until a 6 is obtained. So find the probability that a 6 is obtained for the first time on the 8th throw. So it means that they roll the dice 6. They rolled the dice 7 times, 8 times, and they failed on the first 7 throw. So it's a geometric probability, and our probability of obtaining a 6 is 1 over 6. So the probability of having our first success on the 8th attempt is, you can see here, P is equals to 1 over 6, hence Q is 1 minus 1 over 6, Q is 5 over 6. So first 7 attempts we failed, and then followed by a successful attempt. So plugging in our values in the calculator, we should obtain 0.0465, rounded to 3 significant figures. Right. Now find the probability that a 6 is obtained for the 3rd time on the 7th throw. So let's think about it. It means that out of 7 attempts, we have in total 7 attempts. 1, 2, 3, 4, 5, 7. And then we succeed on the 7th throw. And then it can be either success here, followed by fails, or maybe success here, followed by fails, and so on, so on. So let's try to think. I haven't done my revision yet, so I might be wrong about this, but let me think about this. Okay, for now, let's just put that the fact that we have 3 successful attempts and 4 unsuccessful attempts, but we want such that the 3rd successful attempt is on the 7th throw. Now how does that work? So we're gonna rearrange. We're gonna arrange for the first first 6 attempts, we're gonna arrange, or yeah, we're gonna arrange 2 successes and 4 failures. And so I think it'll look like something like, no, I don't think it'll work. Maybe. You know what? Let's just put 3 P's, 5. 3 successful attempts, followed by 4 unsuccessful attempts. I don't think this is the right, we're going the right direction, but it's better than nothing, I think. Just put our answer there, 625 over 2799936. Then we'll get back to that later once we figure that out. So we've reached the 3rd question. This might be a little bit tedious. We have 27 employees, each of 2 companies. So we have 3 to 6 for browns, 3 to 7 for greens. This is the key we have. Okay, now we need to find the median and inner quartile range for the annual salaries of employees at Browns. So the first thing we can do is just find all the Q1, Q2, and Q3. Yep. Okay. We have 27 employees, which is an odd number. So what happens in an odd number is, say we have 27, we plus 1, and we divide by 2, then we'll have 28 divided by 2 is 14. So we need the 14th number. Okay? So we need the 14th number. This corresponds to the median, the middle number. So that should be 1, 2, 3, 4, 5, 6, 7, 11, 12, 13, 14. So this is the median. We have 3, 2, 4, 0, 0. For our Q1, it's the 1/4 out of the previous 30 numbers. So, I mean, 1/4 out of all the numbers, or the middle number between the first and the median, the first value and the median. So we have here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13 numbers. So which number is in the middle of 13? So just put 13 plus 1/2. That's 7th number. We have 1, 2, 3, 4, 5, 6, 7. This is our first quartile, 3, 1, 3. And then similarly, we can find Q3, which is just the seventh number after the median. So 1, 2, 3, 4, 5, 6, 7. That's 33500. So our interquartile range should be Q3 minus Q1, 33500 minus 31300, and then I'm putting that in my calculator, and we have 2200. 2200. Okay, so that's the median and the interquartile range. Moving to the next part, the annual salary of employee. Bronze is denoted by X $1,000, Y $1,000. Okay, sum of X is this, and okay. Now we need to find the mean and standard deviation of the annual salaries of these 54 employees, which means that we need to total up. So if we wanted to find the mean, it's just the sum of X divided by N. In this case, N is 27. But we want to find the mean of these employees. I don't know if that's the correct notation, but let's just put mean. So the mean should be the sum of X plus the sum of Y divided by 27 plus 27, or 54. And then we'll have 878.3 plus 896.5 divided by 54. So we have now is 3 plus 9.5. We have 54. We have 493 over 15. Okay. Now, to find the standard deviation, oops. Okay, it's gonna be using the formula of sum of X squared when we add sum of Y squared divided by N minus our mean squared. And yep, so it'll be 28616.09 plus 29815.63 divided by 54, and then minus 493 over 15 squared, and put that and square root. So we should obtain 28616.09 plus 29815.63 by 54 minus our mean of 493 over 15 squared. The square root of that is 1.36, and that's rounded off to 3 significant values. Let's just round off our mean value here is 32.9. So that's in thousands. Next, we move on to question 4. This is a probability question. A probability question. Okay, question for 8 marbles and 3 blue marbles. B, 4 marbles, 1 blue marble. 4 red marbles chosen from A. If it's red, it's discarded. If it's blue, it's placed in bag B. So if it's red, inside blue, there are 5 marbles. Wait, let me... So we want to complete the tree diagram. So bag B has 5 marbles, and if it's red from bag A, it remains 5. If it's blue, then it'll be put inside blue, and then we have 6 marbles. So bag B. So assuming in bag A we took out a red, it doesn't affect the marbles inside B. So this is it. And now we'll complete this tree diagram. Now remember that if it's red, then it doesn't affect. Wait, this is bag A, so yeah, we took out now from the previous attempts, right? We took out these. We took out one bag, and then it's not replaced. So, oh wait, now the second statements. It says here that after choosing the marbles from bag B, it's the same thing. If it's red, then it's discarded. If it's blue, then it's placed in bag A. So if it's red, right? After we took out a marble from here, we'll be left with 10 marbles. But then we take out a marble from B, and then we took out a red, so we discard that marble. We don't put it in bag A, so it remains 10. So if it's red, then it remains 10. I should put it in the more convenient. Let's put it here. Now if it's blue, however, one of the blue marble from bag B is put into red. So from 10 it goes to 11. So 11 here. Out of 11 here. Okay, so red. Let's say on the first attempt we took out a red. Oh, sorry. From bag A, from our first attempt we took out a red. So from 8 it turns to 7. So we have here 7 out of 10. And the sum here should always be 1. So 10 out of 10 minus 7 is 3. Now for the blue case, for the case in which the second attempt was blue, this here, the one blue marble, is put into the bag, into bag A. So we have previously 3, it goes to 4, and red here it remains 7. And then here it's blue, so it's 2. This is 8. And then this here goes back 3. This is 7. No, this is 8. Okay. That looks right. So find the probability that all 3 marbles chosen are the same color. So we want probability of blue, blue, blue intersect with red, red, red. So we'll just so the probability of blue, blue, blue it's the bottom one, so it's equal to 3 over 11 times 2 over 6 times 3 over 11. And then intersection means we just plus. Oh, no, it's not intersection, it's a union. So if it's a union, then it should be a plus. I mean, it's plus minus the intersection, except we don't have any intersection. These are all these events don't ever happen together. So red is 8, 4, 7, 11, 5, 10. 8, 4, 7, 11, 5, 10. Let's put that in our calculator. Right. Let's move on to the next question. So on any given day, Cooper either wears a blue jumper or a green jumper, or he doesn't wear a jumper. So blue is 0.6, green is 0.3. So let's just draw our tree diagram here. We have blue, green, or no jumper, so X, 0.6, 0.3, and then these three probabilities should sum up to 1. So here is 1 minus these two is 1 minus 0.9, so we have 0.1. So whether Cooper wears a jumper of either color or doesn't wear, it's independent of his choice on any other day. So yeah, it doesn't affect. So now we have, in a week, there are 7 days, and we want such that, okay, so this is, we define event X such that Cooper, let's write his name in capital, define event X such that Cooper wears blue jumper. Right. So the probability is, it's a binomial event, and there are 7 attempts, and the probability of success is 0.6, and we have failure is 0.4. So there will be, we want probability of X is at least 5. So that means it's X equals to 5, 6, and 7. So then we have 7, 5, 0.6, 5, 0.4, 2, plus 7, 6, 0.6. Oops. Okay, then we just put that into our calculator. hope I don't make any mistakes in plugging in the values into my calculator, but I got 6561 over 15625. Okay, moving on. Now, use a suitable approximation to find the probability in any 150-day period Cooper doesn't wear a jumper on fewer than 22 days. So, doesn't wear a jumper means we have event X such that Cooper doesn't wear a jumper, and we'll define that as a binomial event. In a 150-day period, the probability of success is 0.1. So we want the probability doesn't wear a jumper on fewer than 22 days. So we can use an approximation method by using the distribution table, binomial distribution. So a normal distribution. So we should have a correction. Sorry, not a correction. It's approximation correction. I think I forgot what it's called, but it should be px less than 22.5. I think it might be called a normal correction. Or maybe an approximation correction, but yeah, we'll correct that if we got that wrong. So px less than 22.5, and then using then we'll have our z-score of, oops, I forgot to list down. Our mean here is np, or 150 times 0.1 is equals to 15. Meanwhile, our standard deviation is npq. All right, so that should be 27/2. And instead of that, so z-score is 22.5 minus 15 divided by 27/2 square root. So it should look something like this, but you should make it maybe a little bit cleaner. But let's just get on with it. So z less than we have z less than 2.041. Or do I need, I think I need this last digit here. So if you draw a normal distribution, we'll have, it's probably around here. Now let's look up the normal distribution table. I'm looking it up online. So our figure is 2.0412. So 2.04. Oh, so it's only up until 2.041. So it's 0.9793 minus 0. So it's 9793. So it's, yep. And that should be the answer. And maybe we round it off to 3 significant values. 979. Right, moving on to the next question. Factory produce chocolate bars. Weights of the bars are normally distributed. So let's have X normal distribution with mean 155, standard deviation of 6. I think we should have also put that here. Normal distribution 15. 27 over 2 is what? 13.5. Yep. Okay, so yeah, back to the question. Say we have 350 bars. How many of these would you expect to weigh between? So probability of having our bars weigh between 148 and 160. So we convert that to z-score. We should maybe use a larger space. So it's 148 minus 155 divided by 6. Oops. That should be a z now. (160 minus 155 over 6). And then we'll get negative 1.167 and 0.833. So when you look that up if you sketch a graph, it'll look like this. So it's quite easier if we do it this way. It's equal to PZ less than 0.833. All right. And minus a PZ greater than negative 1.167. No, less than, sorry, less than negative 1.167, right? So that's just PC less than 0.833 minus 1 minus PZ less than 1.167. So that's just 833 plus P. Yep. Right. So just look up this is the z-score table. 0.833.8. So that's 0.7967 minus 8. 7967. 7967 minus 8 is 59. Is it? Okay. And then plus 1.167, 1.167. It's 8770 minus 14. It's 8756. 8756 minus 1. So in total we have 0.6715 or 0.672. Right? Okay, let's move on to the next question. Oh, it's the next part. So we have a second. Oh, yeah, I just forgot that we have to times this by the number of bars. So it's just number of bars times the probability. So it's 350. Yeah, so don't round it off yet because it's not the final answer. So 350, right, times 0.6715. Then we'll have 235.025. But we'll round that off to the closest whole number. So it's 234 bars. So we have a second factory. This is, let's just use y, then by normal. We have a mu, our mean, and our standard deviation. Yep, so let's continue. Tests show that for bars weighing more than 114, it's 8% or 0.08. So, and then for bars weighing less than 99.5, it's 20%. So yeah. First, we gotta convert that to the z-score. And then we have here, just know that if it's less than 50%, right, you see that it's over here, so we have to flip that over. So if it's less than this, then it's 1 minus 0.08. Or 0.92. And then we just reverse that from the distribution table, 0.92. So we look for a 0.92 in the table. So that should be 1.415. 1.415. So this my bad. This should be 1.415. Let me double check that. 1.415 is 0.9200. So next part is this one. So let's convert that to our z-score. Oops. So the z-score of 99.5 minus mean divided by standard deviation 0.20, and then look at the graph, sketching the graph. We have the small part, so we want to flip it. So if it's greater, you can either flip this, flip the sign, or you flip the x and the mean. So let's flip the x and the mean. We want such that the sign is always pointing to the left. We want z is less than this. And so this way, we will have this graph. So we just have to find this. And then that is 0.80. We take a look at the table, looking for 0.80. Perfect, 0.80. So the closest we have is 0.8023 minus 22. So 0.8023 is 0.858. So 0.858. Now, two variables, two equations. All we have to do now is simultaneous equation. Maybe we can add this. You can solve this simultaneous equation any way you want, but I'm doing this in a way that I find very easy. Pop that off. And here we have let's not use the rounded value. Yep, so yeah, we obtained the mean and the standard deviation. Moving on to the next question. How many questions do we have left? Okay, we're in the final question. Now this might be the hardest question, but let's just get on with it. How many different arrangements are there of the 10 letters in the word Seychelles? When you find this question, rearranging a letter in a word, the first thing you do is list down any repeated letters. So in this case, we have two S. Let's list down. We have two S's, we have three E's, and then we have two L's. So there are in total 2, 3, and 2. So in this word, we have 1, 2, 3, 4, 5, 6, 7, 8, 4, 5, 6, 7, 8, 9, 10. So to arrange is just 10 factorial. Yeah, it's just 10 factorial. But then we divide it by the number of repeated letters. So we have two S's, 2 factorials times 3 E's times 2 L's. So that totals up to 151200. Looks nice. Okay, how many different arrangements are there of the 10 letters? Which there are exactly 2 letters between the S's, and one of these 2 letters is C. So let's draw up our slots here. 5, 6, 7, 8, 9, 10. So one of these 4 should be here. And then it's a something and a C. And then it's free to go in any of these slots. So 1, 2, 3, 4, 6, 7. So okay, firstly, we can find the number of ways to arrange this four letter combination. So out of 2 C's we choose 1, and then out of 1, 2, 3, 4, 5, 6, 7 other choices. Wait, one of these 2 letters is C, but that doesn't mean that we don't it can't be 2 C's. So yeah, so we have 7 more letters to spare. 7, we choose 1. I think that's 7, right? 3, 4, 5, 6, 7. And then we times 2 factorial, because it can, their locations can interchange. Wait, I might be making a mistake here. Okay, so there should be 2 cases, right? So the first case is one of these 2 letters, there's only 1 C, then it's 6, 1, and then you can times 2. So 1 C. So this is inside, and then we times the other 6. 1, 2, 3, 4, 5, 6, 7, including the brackets. So it's 7 divided by repeated letters include 3 E's. That gives us 20160. Now in the second case is that we have 2, choose 2, and we don't need to times 2 because they are interchangeable. as in it's the same outcome. Then we times. Oh, we forgot to factor in the double L's. My bad. So it should be 10080 here. Okay, and then for this one, it's the same thing. Wait a second. Okay, I don't think we can do that. We might have to list down the cases, the multiple cases of the letters inside the brackets. So it's either CC or LC or EC or any other letter at C. So if it's CC, it's 22, and we times that by the letters outside 1, 2, 3, 4, 5, 6, 7 divided by repeating letters. For 20, we might have to space them out a little. This is our cases. If you got an LC, it's a 2, 1 times a 2, 1, and it's interchangeable. And then we times 7. And then the only repeating letters we have left is E. L. Outside, we only have one L left. So, yeah. That should be six, 7, 2, 0. Now for EC, it's 3 choose 1, which is 1, and then it's interchangeable, and it's times 7. And then we have 2 L's and 2 E's left. So that should be 1, 5, 1, 2, 0. And then our final case is any other letter. So out of the letter choices we can choose, it's only Y or H. So out of these two, we choose 1 times 2 times 7, and then repeating letters E and L. So 2, 3, equals to 3360. I believe then we can then sum them up. And in total we have 25620. Okay, how many different arrangements are there? Wait, of the 10 letters in which... Okay, yeah. Of the 10 letters in which there's an S at the beginning, an S at the end, and the 3 E's are not all next to each other. So... let's think of this. Okay, so we can arrange some kind of no restriction kind of stuff, except S at the beginning and at the end. No restriction. And then we minus S in the beginning and in the end with E together. So then we are left with S end and beginning with E not together. Yep. Let's take a look. So S in the beginning and the end at the end. So it means that we just don't put them, we just neglect them. And so it means we have to arrange an 8-letter word. 1, 2, 3, 4, 5, 6, 7, 8. And then it's just random between the letters E, Y, C, H, E, L, L, E, S. So it's just 8 factorial divided by repeating letters 3E, 2C, and 2Ls. That gives us 1680 different arrangements. And then for the cases in which E is together, it'll be 1, 2, 3, 4, 5, 6, 7, 8. And then it's E here. So it's basically we are arranging 1, 2, 3, 4, 5, 6 slots with C and L repeating. It's 180. So in the end, we have 1680 minus 180 should be 1500. Are we at our final question? Okay, so final question. 5 letters are selected at random from the 10 letters in the word Seychelles. Find the probability that these 5 letters include the 3 E's. So we want the probability. Let me think. 5 letters include the 3 E's. So if we include the 3 E's, then so for this one, I hope I'm not wrong. Out of 10 letters, we choose 5. Any combinations? we want such that we choose 3 and then we choose 2 out of the remaining. So that should be one out of 12. Is that correct? Okay, I think we're pretty much done, and I don't think I can solve the one question we left out. So let's just refer to our marking scheme, right? Moving on to our first question. So we made this, then we made this successfully. So we earned all the correct answers. Yep, so 14/9, that's the answer. Right, so this one, it's x is not equals to 2, given that x is greater than 0. But it says here that so there are P1 and P3, 1, 2, 3. I don't know what went wrong here. I'm going to have to check up on, check up on the answer. I'll take a look at the examiner report. Examiner report. (9709) Yeah, so it looks like we haven't got the examiner report, so I'm gonna have to ask AI to answer my question. So let me look at the let me copy the question. So my mistake was that the choices should only involve 1, 2, and 3. As in, -2 is not greater than 0. Our choices should only be positive. So this is wrong. Okay, so it should have been 5/7. So I'll take note. And yeah. Okay, next question. 6-sided die. Yep, that's correct. Right, then we're gonna explore this question. So it should have been out of the first 6 questions, 2 of which are 6s, and we times. There are 4 failures, then 1 more 6. We should be getting 0.0335. Yep, so we got 0 for this one. So far we've lost 5 marks. That's devastating. Let's hope we don't repeat. It's 3 marks. What does condone mean? Accept. Condone if B1, B0 scored for me. Oh, so we didn't get this mark because we didn't put it in thousands. So this one is B1, then B0. So if it's V1, V0, then this should be accepted. A1, then everything else here. So we got a 4. 4 5 1 5. Red blue. 7 3 7 4 out of 11. 8 and 2 out of 10. 8 and 3 out of 11. Red blue. So that's 3 marks. This one. One 307 3025. Yep, it's 2 marks. So for this one, I think we should have we definitely should have put that round that off to in that form. So that's 2 marks. So this thing is called continuity correction. But the C should have been 1.1769. I'm going to take a look and see what went wrong over there. $22.5 minus 15, 13.5. Yeah, so apparently I got... Oh! Yeah. This here... Wait, no, it's 15. It's 2... Oh, it's 21.5. Wait, why is it 21.5? So it says here, use continuity correction to 1.5 with 22.5. But why is it 20? Oh, so it's less than, it's not less than or equal. So 22, if it's less than, then it's not inclusive of 22, so it's 1.5. If it's less than or equal, then it should be 22.5. So we got until here. And the markings scheme says here we probably got around 3 marks out of 5. Let's just move on and we'll take note on that mistake. Ah, shoot. So what happened here? we are doing more and more mistakes, it appears. 0.8. Why is it 7975? 1.167 should be 0.877. Wait, what? You got a 0.975 while I got a 7959. I genuinely don't understand. Wait, oh, no. Um, okay, so for my 1.111667 should be 8756 and they got 8784. Wait, I genuinely don't understand this. I mean, I almost got the exact value. Eight seven 83. No, genuinely, I got 1.167. So what went wrong here? 1.16. So 8770. Ah, so my mistake was. Ooh, so for. Yeah, my bad. So for my table, it says add, not subtract, as I usually use. Subtract 1. So it's 8770 plus 14. 8784, so it should have been 8784. So everything down here I got incorrect. So I secured approximately, so that everything's gonna be wrong, fortunately. So I think I probably gained just 2 marks. Then going down here, I mean, we did obtain this. Okay, let's just zero out this part in hopes that we do the other parts.
We have to be careful.
So this one I got this one wrong, completely wrong. Might have to check this one out later. Wrong again. This one I got right, at least. So yeah, good job in securing whatever we have left. Just 3 plus 1 plus 0 is 2, 3, 2, 2, 3, 4, 3, 1, 1, 3. So in total we have 28 marks out of 50. Sounds like a total failure, but we'll rebound on the next question paper we attempt. That's, yeah, 28 out of 50. It's just embarrassing. Let's take a look at the grade thresholds. 5-1 paper. To get an A, we needed 41. 37 for B. 29 for C. And finally 22 for D. So bad job, not good. I mean, I lost approximately 10 marks here. Wait, no, 2 plus 5. 2 plus 5 is 7. I lost about 7 marks only just because I didn't read my table correctly. 7 marks, that would have been 35 at least. 35 would have gotten me a C. And so I should be careful for the next time. Well, thanks for watching.